How are we doing again? This is Marlon Echeverry from the Natural and Social Science Multimedia Lab. Today we're going to be looking at a concept known as the octet rule. The octet rule involves valence electrons, and we're going to look at that shortly. But before we begin discussing the octet rule, we do need to talk about what are known as the noble gases. So if we look at the periodic table, we can see that column 8A, group 8A of elements here, are known as the noble gases. So the key thing to understand about the noble gases is that they're very unreactive. The rest of these elements, when you combine them, you can actually have lots of different type of reactions. With the noble gases, there are very few reactions. And that is quite strange when you think about it, that there's only one column in the periodic table that does this. So the key idea is, why are the noble gases so very different from all the rest of the elements that we have? Well, the idea is these elements have their electrons interarranged in a way that's a highly stable, what we call electron configuration. And they have an exact number of valence electrons. And since they're in group 8A, how many valence electrons would that be? It would be 8 valence electrons. That's what's important to understand about the noble gases. Some people like to say that since they're noble, perhaps they're of the regal class and they don't like to mix with the common elements. So just remember, noble gases do not like to mix or react with the common elements. So let's take a look at this principle again. How many electrons did we need in order to be highly stable? You need 8 valence electrons. And if you have 8 valence electrons, that will give you a highly stable electron configuration. So 8 valence electrons gives you a highly stable electron configuration, except for one element, which we should mention briefly. That would be helium. If you look at helium, it only has 2 valence electrons, but yet it is a noble gas. So do be aware that helium doesn't have 8 valence electrons. So how do the rest of the elements achieve this low energy state? How are they going to be able to obtain an electron configuration where they have 8 valence electrons? Well, the idea is some of the elements are going to go ahead and lose electrons. For example, the metals tend to lose electrons. The nonmetals on the right of the bold staircase here are going to go ahead and gain electrons. And other elements, when they combine, actually share electrons. So this is what we're going to start looking at next in the next video to try to understand how some elements lose electrons, some gain electrons, and then eventually we're going to talk about the sharing of electrons. Thank you.